At Simio, we're in the business of showing you the future. Our intelligent technology gives you unprecedented insight into complex systems to identify and solve today's inefficiencies and tomorrow's challenges. The Simio solution provides a low-risk opportunity to drive transformational change. Our true digital twin models capture all the constraints, business rules, and decision logic that define the operation of your system. When powered by your data, easily evaluate unlimited scenarios and deliver optimized solutions. No matter what industry you're in, eliminate your greatest operational process and scheduling challenges with a Simio digital twin. See your future success, Simio.
All right, welcome everyone. My name is Dan Vassolini, and thanks for jumping into our solution series here in June. Let me get started. Maybe. Here we go. All right, again, let's get started. My name is Dan Vassolini. I'm the VP of Global Sales over here at Simio. Doing most of the presenting today is going to be Adam Snaith. He is our Solution Engineering Team Lead. We will get started here in a second. If you see the QR code on the screen, we are always looking for feedback on our webcast, so please feel free to scan that QR code and answer a few simple questions on there and give us feedback on this webcast and on all future webcasts. A few housekeeping items before we get started today, and this is definitely going to be important because as I just mentioned, and as you just saw the attempt to get started, WebEx has made a few changes since our last webcast. So I will talk about those here in a second. But first and foremost, today's session is being recorded for replay purposes. You may have heard that when we started the webcast. If you'd like to watch this session, either rewatch it or invite a colleague or talk to someone else within your organization to watch it. We will have this up on our webpage within 24 to 48 hours usually. On the Simio webpage, you will see a resources tab. If you drop down that resources tab, I think it's the second drop down now on that is the Simio Solution Series, and every solution series that we've ever done, going back 3 years now, are up there. So we have topics, we have dozens and dozens of these webcasts and dozens of topics. So feel free to go out there, explore, and rewatch or watch any of the former webcasts that we've done. So you should be on mute. All participants entered on mute. In the past, in WebEx, there was a Q&A box on the right side of your screen. That Q&A box is no longer there. There should be something popping up called Slido or a polling area that'll pop up on hopefully the right side of your screen. If you wish to ask a question, just type it in that polling area. All questions are private and come directly to the presenters only. So if you ask a question, I will get those questions as they come in, and I will do my best to read them out in the appropriate time frame, whether it's during something that is presenting or perhaps in a break that he takes or at the end of the session. We do try to leave some time open at the end for Q&A. So if your question is typed out and we don't get it during the presentation, more than likely we'll get to it at the end unless we run out of time. If we do run out of time, that's why I put our email addresses up there at the beginning. You can always reach out and say, hey, I asked a question, you guys didn't get a chance to answer it, or if for some reason I missed your question, you can always reach out to us directly and we will definitely get back to you. Like I said, and one other important thing, if you accidentally close the Slido polling area by hitting the X, all you need to do is go into the apps and simply reopen the Slido polling app, and it should pop back on your screen. Future webcast, we're on a monthly basis. Our next one is scheduled for July 16th. It's going to be Work Smarter, Not Harder, a data-driven approach to modeling labor. So if you have attended this webcast or you're watching this on the recording, feel free to go in and get registered for that next one at any time. SimioSync 2025. If you did not attend SimioSync 2025, our live user conference, all of the presentations are available to you. Some great great presentations occurred during that 2-day session. I would highly recommend simply go to the Simio webpage, and it's the third drop-down Simio Sync conferences, similar to the webcasts or the Solution Series webcasts, how all of our prior ones are on there. All the prior Solution Series or Simio Syncs are also out there, but the 2025 presentations are out there. Just simply click on that, and you will see all the people that presented, as well as the presentations that went along with it. Feel free to go out there and watch any of those presentations. We had a lot of good ones from all around the world. And from my perspective, thank you for attending today's session. We do appreciate you attending live. If you're watching on recording, we do also appreciate you watching the recordings. There's your QR code again. So if you didn't have a chance to scan it when I had it on the screen prior, there it is now. Feel free to scan it and give us feedback as we go. And if there are any issues or problems with the Q&A, the Slido polling area, feel free to kind of nudge us, let us know. This is our first time running through it with this, so hopefully there are no issues, but if you do have any questions or anything, just feel free to reach out. Other than that, Adam, I will turn it over to you.
Thank you, Dan. Welcome, everyone. Really excited about this session, energizing your modeling with autonomous vehicles. So a few slides here to set the stage. And Dan, before I go too far, can you give me a thumbs up that you can hear me all right and see the screen share?
Yes, sir. Everything looks good.
All right. Wonderful. So we see industry trends, in particular in manufacturing, logistics, warehousing, towards automation. And that can be both a large for a significant financial investment and also a daunting process change to get your head around. So the business wants to invest in autonomous vehicles. Let's use Simio to understand the future system performance, justify ROI, and avoid implementation bottlenecks. I really like this topic because at Simio, we talk a lot about the design to operate journey of digital transformation. And I think AGV systems are a great example of an application where there's really nice use cases for both design. So maybe you're in the sales cycle with a vendor and trying to understand how many vehicles you need to meet your target rates. Perfect use case for Simio. But through the implementation, and then when you're actually operating the system, Simio can still be used to evaluate some of the finer points, looking at manual traffic, the battery charging, maintenance on the vehicles, and we'll cover a lot of those topics in this session today. So here's what we have planned. We will start with data-driven picks and drops. You'll see shortly that our system is going to have an inbound logistics area where we have a few receiving docks. And we're also in data tables going to specify flexible load and unload durations for the vehicles, picking up pallets in this case at those areas and dropping them at their destinations. We'll also see the ability to easily enter arrival rates at those different dock doors through data tables. Next, we will also use data tables for destination mapping. So I'll show you how we can select drop destinations based on where we're picking the pallet. Then I will demonstrate how we build the travel network using our recommended or best practices, and we'll cover custom objects that are used to help us out with that, along with intersection management. So in these systems, it's really important to understand congestion. And there's often rules for areas where vehicles may intersect or turn a corner. And often you want to limit access to that intersection to one vehicle. It's often the case as well in the pick and drop areas so that the vehicle has space to do the activity. And we'll also use some neat techniques to track wait time at the intersections and get some visibility into where there may be congestion. Finally, we'll look at battery charging as well, as these are electric vehicles, and we'll run an experiment on fleet size and check out some example KPIs in these systems. Switch over now to Simio. All right, let's get started. let me get my screen organized a little bit better here so I can stay on task. Okay, good. So relatively simple system. On the upstream, we have 3 source objects used to model inbound receiving. And we have a simple loop that the vehicles will travel on to deliver parts entities to a couple of sinks. So you can imagine these are racks, production areas, or staging areas for material that we need to, deliver into the system from receiving. So we will start with the upstream area. And I would say this is going to be somewhat of an intermediate to advanced solution series, which I'm excited about. So of course we're focused on AGVs, but I'm going to convey, a lot of different techniques for verifying the model behavior. We'll focus heavily on data-driven and also some object customization. So my hope is that you learn some new things today. And certainly, as Dan mentioned, as questions come in, please ask away. All right. So we'll get started. And once I get to the travel network portion, I'll provide a little more clarity on how I actually built this model. But let's get it running and focus on some of the initial details. So I select the source object. I'll just run the model and step into it so we can start to see what happens. So the sources are creating pallets in these receiving areas. And how do they do that? So the first thing you'll notice is a table reference for inner arrival time, table arrivals, arrival rate. So immediately, we're going to switch over to the data tab and view that table arrivals. So I have an object property column to create a record for each source object. I've also selected auto set table row reference true. If true, then at initialization, the element or object in this case pointed to by each row in the table will have a reference set to that row. And for each server, I specify with an expression property column the arrival rate of parts in that area. So using an expression column allows me to make that either deterministic or stochastic, so I can simply enter 5 minutes. You'll see I also give that column time, units, and minutes, or an expression, one of our random dot expressions. And that auto set table row reference true allows each source to resolve this expression through its row reference. If you have experience with Simio data tables, the syntax here is table name dot column name. So I need to sort of further inform, what row, and we have a nice feature there with the auto set row reference. And a tool that I use more and more in my Simio modeling is the watch window, which allows us, while the model is running, to sort of click into an object and see state values, other functions built into that object, and particularly useful in this case, table row references. So I can confirm that source 2 has a row reference to row 2, which is its corresponding row in that table. So it's able to resolve that rate. And let's just watch the model run for a little bit here. And already the first thing we'll do is verify those arrival rates. So verification and validation, very important for simulation modeling. Verification, I think about the E in verification for errors. I want to make sure that what I've intended to model is actually occurring. So first thing I've done is create some simple labels to count output buffer number enter. How many parts have been created by this source? And over time, we'll fast forward and see we get 36, 49, 36. Now, why is that the case? We want to make sure we understand why that's the number created at each source. So source 1 is probably the easiest example because I've just said every 5 minutes. Some quick mental math gives me 12 an hour. And for my run ribbon, I'm running for just 3 hours. Source 3 is similarly centered on 5. So if we were to run replications, it may not be 36 every time, but it will be generally in that ballpark. Source 2, however, has a bit of a faster arrival rate with expected value of 4. So we see more parts coming in from source 2. Now I'm also using a time plot from our animation ribbon to track parts in queue waiting to be picked up at each inbound area. And what you'll notice, so we'll just run this pretty fast. I have the vehicle fleet size set right now to essentially keep up. And by the end, I'll show you how I got there. But you can see that we don't appear to have any sort of massive queuing at those inbound areas. But if I were to undersize the system and reduce the fleet size to just 2, we would see over time that queues start to build. In particular, most likely at source 2, because that's where we're bringing in the most product. So we'll just let that run for a little bit, and if we span the queue, we can see now we're not keeping up as well. So I find that just some sort of base level, tracking of things is really helpful for me as the modeler to understand the behavior that I've tried to model and how the system is performing. All right, so we're off to a good start. Now, when a part arrives, how do we tell the system where it needs to go? So as mentioned in the slide, I do that through data tables as well. So this was actually covered recently in a Simio learning bite on our training platform. So you may have already seen this technique. But essentially what I'll do is create a primary key column for each of those output nodes at the source, which is where the routing logic occurs to determine the destination for the entity, encountering that node. And I have a related table or child table where I can provide weights for multiple destinations, but only destinations that are eligible from that node. So a part arriving at source 1 or dock door 1 will route to either server 3 or 4 with equal likelihood. Source 2 will send parts to sync 1 or sync 2, favoring sync 1, and source 3 will send parts to sync 1 or sync 2 with equal weight. So that's sort of a shortcut to view into the related table, but I have all of that information stored here in my table destinations. And the next piece to this is using that information. So when I think about data driven, the first piece is, okay, let's get the data into Simio. When it's small like this, I will often just create it manually, or when it's made up and I don't have a data source. But as you may be aware, we have a really flexible set of bindings or data connectors that you can use to pull data in to Simio or build a bridge if you want to keep that connection active if you have more of an operational use case. So really flexible on getting data in, but then the driven part of data driven is let's make use of that. So we saw an example here with the arrival rate. Now on my output node, I've selected specific destination referring to the destination node column in my table. And this bracket syntax after the table name allows me to pass a number, a specific row number. And to do that, I'm going to use the random row function, which if we were looking in will return a row number by sampling the weights from a numeric column. So it's going to randomly sample the weights specified here and return either 1, 2, 3, 4, 5, 6. Now, just as we've done before, we ought to verify that. Let's make sure, how do we know this is doing what we expect? We can kind of watch it, and follow vehicles around to see, but we can do a bit better than that. To do that, I'm going to focus in on source 3 and set the weight to 0 for my first destination there. Another nice feature while you're building up your model is the stopping condition on a source. So one of my first milestones for a model is usually, let's get one order flowing through the system, or let's get one part flowing through the system, just to start to get kind of the end-to-end flow. But you can also, in this case, I'm going to disable 2 of these sources by setting their max arrivals to 0. And we'll slow things down a bit and watch, see what happens. So now, and I skipped a step in my head. Before I run, I try to form an expectation of what will happen. So first off, I only expect parts to arrive at source 3, and that expectation seems to be true. And those parts, as we saw before, arriving about every 5 minutes. And we're seeing that, so far it looks like they're only going to sink 2, but we still don't know for sure because, if it was a coin flip, we've only watched 4 or 5 of them so far. So let's fast forward all the way through. I'll see that I had 37 parts arrive. One of them is still in transit, but I've added some tracking in my table drops, which we'll cover a bit more as we go through, to count the number of parts at each drop area. So I confirm that all of them have gone to sink 2. Maybe we'll just do, a second or a third test, right? So we'll switch the weights, give it a run, see what happens. Now our vehicle takes parts over to sink 1. Again, we can confirm that all of them have gone there. And when we set it to a coin flip, I would expect approximately half of them to go to each area. But as you know, with variability, when the weights are 50-50, as we approach a very large number of activities, this gap would close. But I feel okay about this for now through our verification efforts. So hopefully you're already starting to see the vision and the approach here is, giving me some really nice toggles in these data to quickly, change the way the simulation is behaving. Next, we are going to focus on the load and unload time. So the standard Simio vehicle object, which was the base of my custom vehicle, we'll talk a little bit more about why I have a custom vehicle, has a properties for load and unload time. And again, I'm using a table reference to make that more dynamic, more flexible. So let's take a look at the table. This table stores our activity types. So if you have to, pick from a high area, it takes a bit longer. Presumably, someone's done a time study, and what I've found is that, often from sort of a visual digital twin perspective, people modeling these systems want to really see, the rotation of the vehicle. Often the vehicles will kind of back in to do a pick and then rotate to travel out. You can certainly get into that level of detail, but if you're looking at this more from an analytical perspective, doing some time study and just capturing the duration gets you very, very close, right? So we're assuming that, this 42 seconds covers any rotation that's happening once the vehicle gets to the picking area, the forks on the vehicle, if it's a lift truck, sort of going up to the rack. So we store those durations in a data table, and then we do a mapping essentially to each picking area and each drop area through a foreign key to inform those areas what type of activity happens there. So 2 of my sources are a high pick, the third is a floor pick, and in the drop areas we have table drops, line drops, and rack drops. Now, you can probably guess what I'm going to do next. How do we make sure that those durations are really happening? So let's slow this down, and we'll focus on one activity. We'll just focus on the first one. So my vehicle enters, and it looks like my vehicle 1 bracket 2 is currently doing a pick at source 3. So our expectation is that source 3, being a floor pick, would have a duration of 24 seconds. And I'm going to use the Gantt chart to confirm that once the pick activity is complete. So the vehicle's pulled away, and by enabling interactive logging, and I'm also logging the vehicle's activities, I can click in and see this activity hasn't completed, which is why the bar extends, definitely up to the current time. But by hovering on that bar, I can already confirm here that the load duration is 24 seconds. Probably get another one here pretty quickly before we follow our second vehicle down to its drop. But source 2, what do we expect? High pick, so the duration is 42 seconds. We're feeling all right so far about the picks. Now, another nice feature I like, whoops, we already looked at watch, is this camera tracking feature. So if I click that on and off with a right click on a particular object, it's going to set that item as the camera placement in my view ribbon. And then I have some options to, if I want to follow along behind, that can be pretty neat. If I want to move camera with the object, I can do that. And we're just going to follow this vehicle along to its destination. In this case, that's sync 1. So we'll wait for the activity to complete and then take a look at our drop duration. Sync 1, we've specified table drop. So that should correspond to a duration of 35 seconds. Now we go back, we see that activity is complete and confirm our unloading duration is 35 seconds. There's one other small piece to this. So it's working. Well, how is it working? Why is it working that way? Just want to make sure. All right, camera placement is off. So we're going to start to get warmed up now with a little bit of process logic. So I have 2 pretty simple processes, one on the output node of each source and one on the input node of each sink. So we flip over to processes and take a look. So at the source, I have both entities and vehicles entering that node. You can probably tell already I'm a stickler for verification. So whenever I craft some process logic, I put a breakpoint in on the first step and see, all right, the first time that process triggers is entity 89. The syntax here is vehicle to check if the associated object is of some instance or definition type, false. So just do nothing for the entity. Now we can bump our breakpoint down the line a bit. I like to watch in the facility view so I can sort of understand the timing. And now my vehicle's also entered that node to do the pick. And I'm going to set row, table arrivals, using row for key of the node's associated object. So my logic's executing at a node, output at source 3. I have a function on nodes to return, in this case, the associated object, or source 3, which is my key, right? So row for key is pass a key value, return a row. So when I step forward, this will tell me that for the vehicle, I've established a reference to row 3, which through the foreign key tells me about the activity type. And I do the same exact thing there at the sink. So each time I do a pick or drop, I just sort of tell the vehicle what row to look at so it can grab the activity type and the corresponding duration. The reason that's important is because on those load and unload time properties, I have a table reference there. So I need to resolve that row. I do that using those set row steps. So already with a few simple data tables, we've got some nice detail here in the model. Now, next, I want to talk to you about how do I build this travel network? Relatively small system here, so I've done it semi-manually. But when I started with the blank canvas, essentially what I did, bring out some nodes. Now, if this is a real system, you might have a floor plan or a CAD drawing blueprint that you want to import. So if you have that on the canvas, you can sort of multi-select and place your nodes, anywhere there's going to be sort of a turn or an intersection. Note I am toggling some of the visibility here as we go through just to keep things clean. But there is one sort of key unique piece that's going to lead into our next topic of intersections. So for the paths that connect the nodes, I don't place them manually. I'm actually auto-creating them from a data table because I need a record for each link in order to map the intersections. Now, I'm going to take you through in detail what the intersections are and how they behave. You may have already seen a little bit of the weighting behavior while we're running the model. But all I have here is an object property for this custom path. We'll talk about the custom objects more in a moment. Auto create based on the start and end node entries for each row. So what that looks like when I'm building this is, all right, start node, my basic node 1. I can lean on copy and paste a little bit to make this quicker. And then I'm going to take, that end node from the previous. So you sort of set up the table schema and then just drill through specifying those start and end nodes to get the links. So again, for a small system, pretty reasonable to do this in not too much time. However, if you're modeling large systems, we have implemented on projects some really nice techniques where, for instance, you can automate a data extraction from CAD. So my nodes have, X, Z in Simio, X, Z coordinates, but some Cartesian coordinate. So we've done in the past is have, some Python code or an automation layer outside of the model where we're providing a layout file, extracting coordinates for nodes, creating a similar auto create table for nodes, and then connecting the nodes, also through that code to essentially generate these data tables. The particular application was actually a vendor, so they're modeling multiple systems a week. So that was really an accelerator for them to be able to extract the data from a CAD drawing and build up the travel network in a matter of minutes just by providing the drawing, running the code, and doing a data import. This is something to keep in the back of your mind if you are modeling systems like this. Now, intersection ID, what's this about? So we will flip over to intersections as the primary key, just a string column to codify or provide a unique ID for each intersection. I also auto create a resource. You see these resources have a capacity of 1 that I'm going to use these release to kind of manage traffic in that intersection. Resource 3 corresponds to intersection 3. And we actually added a feature for a very similar project to show link labels to make this a bit easier. So path 17, 18, 19, and 20 are mapped to this intersection 3. So conceptually, what we have is that we want to limit travel in this area to 1 vehicle at a time using this intersection concept. Functionally, to get there, I turn on these link labels, go to table links, and map my codes through the foreign key. Now I will explain sort of why and how this all works through process logic here momentarily. But let's just watch the behavior while we run in the facility. And check my speed factor, go down to just 1. So everywhere you see a resource, I've placed them near the intersection. And they all have a similar look with sort of these bounding nodes. So this area here is intersection 2. And you see that subsequent vehicles have to wait until the intersection is clear. Once that intersection is clear, other vehicles can now enter. Looks like I left a breakpoint, so we'll go ahead and get rid of that. But really, really a nice way to manage traffic. Now we're going to see another aspect of this as well. Collision and deadlock avoidance is very important in these systems when you're using bi-directional paths, paths that allow travel in both directions. We need to avoid, head-on collisions, or we'll get a warning from Simio saying, hey, all progress is stopped because we've got a deadlock. So I use a parking concept here. So when a vehicle arrives at a node that another vehicle is waiting at, traveling in the other direction, I'm going to park one off to the side until that node is clear, and then they can pass each other along. A lot of different ways you might approach this. We also have network and path planning features to sort of auto-magically handle deadlocks for you. So really important topic here. If you want to discuss further, certainly reach out and be happy to help brainstorm what's the right approach. Keeping it kind of simple here for now. Just park one off to the side until the area is clear, until the node is clear. To animate that, fun fact, we'll just stop the model for a moment. Every node or basic node has a parking queue built into it that is by default turned on, and it sort of just stacks vehicles on top of it, so it wouldn't look quite as good like parking off to the side if I left on that default option. So I unselect that, draw my own queue off to the side to animate parking station contents of that node. And I do that in a few places just to show you that technique. All right, now the fun part. Let me take a look at time. All right.
Adam, let me just interrupt here real quick.
Yeah.
So we've only had one question come in, which is a little bit abnormal based upon past webcasts. So just to make sure everyone is aware of how to ask a question, either on the right side of your screen or in the bottom side of your screen, there should be apps. And in those apps, there is the Slido polling Q&A. And if you open that, that is where the Slido polling should pop up. There should be a box in there that you can, quote, type another answer, and that's where you would ask the question, and that will pop up to us. So if you do have any questions and you have, you couldn't figure out how to get them to us, that's the best way to get them to us. Thanks, Adam.
Good. Thank you. All right. Let's keep moving because this is the fun part. So how do we get this in? So we see the data, we kind of understand the data structure, we've seen the behavior. Now I want to quickly touch on the custom objects, why these are helpful. So I'm going to drag two basic nodes, my basic nodes out, connect them with a my path, show you a neat technique. So if you're working with collaborators or someone's given you a model with custom objects, when you look at it, you don't really see what's custom about that object. But what's really nice is you can convert it back to the base object, and then you'll see in bold what was changed. So on each path, I've set the default. If you're interested more in custom objects, we have some really nice training content, but creating a custom object allows me to set my own defaults. So every my path I bring out is bidirectional and does not allow passing. Every my basic node that I bring out is calling a process on entered. So every time a vehicle goes into one of these nodes, we're calling a process, and we're going to dive deep into that process now. So looks potentially a little bit scary, but we're going to step through it, maybe spend about 3 to 5 minutes just to give you an idea. Again, there's a lot of different ways you could approach this. So this is just one. So what I'll do is put a breakpoint on that first step. And I'm going to be doing a lot of flipping back and forth here through the facility and processes. So I have a state on the vehicle. Another nice aspect of the custom objects is I can put custom states and properties on them. So when I put a state within my vehicle, every realization of that vehicle has that state sort of within it. So when I click into the watch window, I see next link. Right now it has a value of none, but we assign it using this network syntax. So global next link, start node, end node, current node to my destination. What's the next link I'm about to travel on? This has told us my path 5 because the vehicle's just entering the system and it's headed to one of our docks. So we know that we're about to go on to my path 5. Next, we just check that it's not entering the home node because we don't need to do any of this intersection stuff. And in fact, there is no next link when we go into the home node to park. So I'll just kind of skip over the syntax for the sake of time there, and we will move on to this next check. So now we're checking in table links, row for key based on that next link. Do I have an intersection code, in this case for my path 5? And we'll see that this returns false. Why? Because my path 5 is not part of an intersection. So our first check is, are we going into an intersection? Next, are we leaving one? So I have another state in that vehicle, current int, which we'll see the assign of shortly. Is the node I'm about to go on occupied? In this case, no, so do nothing. Now we move on and we'll watch when we get to the next interesting point in our logic. So now we've realized we are heading into an intersection based on the next path that we're about to encounter. And I'm going to check, has this state been assigned? Is this a new intersection? Am I just entering? If it is, I'm going to use a set row for the token. Definitely some good discussion about this. In my mind, it has to do with sort of memory. It's a little more transient to just set the row for the token. I don't really want the vehicle to kind of carry around memory. So the other option there would be associated object of this process. There's a few options there, but the default is associated object. I don't really want the vehicle to carry around this row reference, but I'm just using it to tidy up some of my syntax down the line here. So we'll step through a little bit more and see. I've set a row reference for this token to row 10 in table links, which also now gives me access to the intersection, right? So the intersection is where I have that resource that I'm going to seize release to help manage traffic. So just continue stepping through. I've assigned that state intersection 2, which we just saw on the table, is the intersection we're about to enter. The node occupied, because if it is, I need to do some slightly different stuff to kind of park pull off to the side. In this case, it's not. I use another state on the vehicle to timestamp the current time that I'm trying to enter this intersection. And then we're going to seize the resource by, again, a table-driven reference to intersections. So it's really nice that I've crafted this process with what I call generic syntax. So I'm calling this in dozens of places at every node, but it's sort of reading, okay, what's the next link? Is it an intersection? What's the corresponding resource? And then seize. If I get the resource, my wait time to get into the intersection is 0. So I just increment that state column with current time minus the vehicle's state. And I'm storing that in a state column here for consumption later. All right. Now let's just drop a few more breakpoints to see what happens next. So now we're exiting an intersection because the logic detects this vehicle has a code and that it's not heading into an intersection. So that state also helps me within the intersection. When I hit this node, it's going to detect, hey, my next link is still in an intersection, but I don't need to do anything unless it's a new intersection. I'm already in there. I've already seized the resource if I got it, right? But when I exit, of course, it's important to release that resource. Now, I'd wanted to show you the allocation queue for that resource because we have another vehicle waiting to enter. So what you see after the release by vehicle 1 is that vehicle 2 promptly seizes that resource and is allowed to enter. So a bit hairy, maybe a little more detail than we usually go into these, but hopefully the walkthrough was okay to give you some context there. Last thing we'll look at is this parking concept. So you can see clearly now I have 2 vehicles trying to go through the same node. So I'm checking whether that node is occupied. And if so, I'm going to park one vehicle off to the side and wait until the node is no longer occupied. And then unpark myself, right? So all in all, hopefully not too bad. Just wanted to give you a bit of a deep dive onto how we model those intersections using resources and data-driven concepts. Really just 2 more topics I want to cover here. I'll try and be mindful of time, maybe just 3 or 5 more minutes. I've put a label on these vehicles that I have since hidden, but I will now reveal. Let's just clean up the screen a little bit. And we'll see that we have some pretty comprehensive battery charging that we've implemented on these vehicles. So if you're really interested in this, it's generally based on a SIMBit called electric vehicle. As all SIMBits do, there's a nice PDF document to walk you through this. So that is the inspiration. But I've done a little more to add this label showing me the charge zone. So when it hits 20%, we're going to recharge. We'll see that behavior up to 90%. And I initialize the starting level of that battery randomly, just to make it a little bit more interesting. For example here, presumably at the start of the shift, the vehicles will be fully charged, but I wanted to make sure we get, one of them down to its threshold so we can see the recharge behavior. So any guesses as to which one it may be when we run forward? Probably this vehicle 1, which starts at the lowest level. Now, I don't want to rush, but I don't feel that we have time to totally cover this in depth, so I'm just going to give you some highlights. And as mentioned, we could follow up if you're really interested in this. But I add some properties to my vehicle within the definition to give the charge and discharge rates and the starting level. So those live within the vehicle definition. When you add properties, you can also categorize them with something custom, which is pretty nice. And I also have some states, in particular, a level state for the current battery level. So a level state has two assignable aspects. What is the value and what is the rate of change there? So more or less, in a nutshell, what we do here, when we start the run, I look at the property value to set the initial level of the battery state, that level state. And then we have one other key piece, this monitor. So I'm watching that state value for a negative cross low battery level, which is given as a percentage, but not as a decimal. So low battery level is set to an initial value of 20. So when I'm at 20% of the full capacity of the battery, trigger a process, or when I've just gone below that. And we'll just quickly look at this process, also implemented within the vehicle, just to keep it nice and compartmentalized inside. We'll go ahead and fast forward. And if I were to trace, we would see that my vehicle one, bracket one, first thing we're going to do is wait until it's empty. Now, another fun fact, if you had a really big system, you can use the entity window to sort of hone in and find that vehicle. Now we'll just follow along, and I'm not going to trace anymore, but I'll sort of bump the breakpoint down. So the first thing we do is just finish, wait till the ride station is empty. And let's use our camera tracking to follow along. So we're sitting at that scan step, waiting for the vehicle to become empty. And once it is, we will take it off shift. So the vehicle color changes because the resource state changed. And we're going to then wait until it gets home, which is the off shift action on that vehicle. I'll show you in a moment. And then we are going to set the rate of change of that level state to charge rate. That was the last thing we'll see here. So we're still, draining the battery until we get back to our charge station, in this case, our home node. And then we change that rate to positive 100, and it was previously negative 75. So the implication is now my battery level is being replenished. And it will continue to do that until it hits 90%. A bit more logic in there to manage that, sort of charging complete. But hopefully this gives you an idea on how we accomplish that. Lastly, I'll just share with you how that off shift action, helps me kind of get back to home when I go off shift. And I use some of the nice string features like string new line to concatenate things in that dynamic label based on the vehicle states, properties, whatever I want to display there, but sort of packing it in nicely to that dynamic label with string new line. Finally, we've got this great model. What do you do with it? Just run a really, sort of simple experiment here. If you wanted to build out something big, you could use scenario generator to help you, but we're just looking at 3, 4, or 5 vehicles in this pretty small system. Tracking average job time. Generally, you don't want to plan these systems over 80% vehicle utilization. Now, I also experiment with the speed to approximate things like manual traffic. Like often these vehicles have some vision, so if they encounter, a manual forklift operator or somebody, walking through the travel area, they will stop. So to get an idea of that impact, we just assume that, the average speed for the vehicle may not be its full speed, and we run some scenarios there. So it seems like we may conclude 4 vehicles should be enough. We're under 80%, even if we, don't run as fast as we think. Sort of counting parts waiting at inbound and time spent waiting at inbound and transit time using some tally statistics. So I'll just leave you with this. In our drops table, we create some tally statistics, auto created, which is really nice for sort of large sets of elements you want to create, just to sort them with the drop area name. And that information all is logged then in my tally observation log. So I see the total job time, and what are we tallying? When I enter the sink as an entity, time now minus when I was created. So when did I enter the system? The difference of when I exited and when I entered. That's what we capture there for job time. We've covered a lot. I'm always a little ambitious in what I try to achieve with the given time, but hopefully you got a lot out of it. You can refer back uh, to the video if you're interested to learn more. I'll stop there. Dan, questions from the
Perfect.
audience?
Yep. Thanks, Adam. All right. In the few minutes we do have left here, so let me address the first question that came up, and then I'll roll some over to you, Adam. So the first question that did come up was, is this webinar going to be available to view at a later time? The answer to that is yes. If you go to the Simio webpage, right across the top, there's a resource dropdown. Under that resource dropdown is Simio Solutions Series, and you will be able to find this webcast as well as any other one we've done in the past available there. It usually takes us about 24 to 48 hours to get the current webcast up there. So if you do go to look for it, in an hour, it's probably not going to be there. But if you look for it maybe tomorrow at this time or definitely by Friday, it will be there for you to view. So yes, 100%, all webcasts are recorded and available for reviewing. All right, a couple questions we have. Yeah, Adam, the first question is more generic in nature. I don't know. I'll let you take a spin at this, but if there's not an answer, we can always get back to the person. And I think from a solution engineer perspective, you might have a better answer to this one. Does Simio have any experience creating models with transit agencies to help plan routes and schedules?
Yeah, so what I would say to explore, we had a Simio Sync presentation a couple years ago from Penske. I'm trying to use my imagination when we say transit agencies, but in general, we have some nice features for GIS and map integration. So I would say generally yes, and let's follow up, see if we could provide a case study or give you a better idea of what that might look like.
Yeah, just from a very high
yes.
level, obviously, anything that's on our webpage, we have disclosure forms or availability that customers are more than willing to share their information. If there is something that we have worked with an agency and we have non-disclosures in place, then obviously we can't specifically mention that. So just keeping that out there.
Yeah.
All right.
Just one more quick thought, Dan. We do a lot more, I would say, with shipping and logistics between sites, between distribution centers, sort of a supply chain level. That when I hear transit agencies, I'm thinking about kind of public transport or something like that, possibly the question. But the features are in there. Definitely Simio is capable to model those either in a supply chain or more of like a public transit context.
Perfect. Yep. Perfect. And what I can do is, as I normally do, I will flash both Adam and my email address up one last time before we end here today. So if you do not get your question answered, or if that was not what you're looking for, you can always reach out to us directly. Next question that popped up just now. Is there a way to produce a PDF sheet of how to recreate this model, or do you have any kind of step-by-step directions, or what would be the best way you would suggest, Adam?
Yeah, well, one thing we can do is share the model. We can provide the model, and I think some documentation could be dreamed up. Absolutely, and hopefully the video is a good reference because I did try to walk through most of the steps as to how it was created with the network, the custom objects, and some of the logic. So yeah, absolutely, we want to support that.
Okay. And like I said, I will put mine and Adam's email address up one last time before we end. So if you do want to reach out to us directly, feel free to. All right. In the limited time we have left, we do a couple questions. Let me just jump into one of these, and if we don't have time for all of them, that's okay. How can we have a vehicle and a worker move simultaneously together or simulate the seizing of a worker as a driver in the vehicle it is driving?
Yeah, really good question. So first step would be through vehicle customization, similar to what we've done. Probably cracking inside the vehicle, and when the vehicle activity is triggered by the logic inside the vehicle, you could seize a worker. You could have a property to specify what worker you want to call, because you might have different types of vehicles. Maybe some of them need a driver, some of them don't. So you could have a property to map a worker instance to vehicle. And then within the vehicle, you could add logic to seize that worker, and maybe add a custom queue to the vehicle so it looks like it's riding along. We do have an example out there of this. Let's talk further because it's a little bit of a dated example, but I think the concepts are still relevant. So that could be a good reference point. But yeah, generally just through vehicle customization, seizing that worker while the vehicle is also busy.
All right, perfect. Let me ask one more question because we're just about out of time. Could we use tables to record these model level states instead of creating custom objects? What benefits are there of one approach versus the other?
Yeah, absolutely. So one example is if you had multiple battery types. It's something I've encountered before on a project. So basically what I assumed is there's one type of battery with these attributes, but you could easily have, a list property here to say, lithium ion or lead acid, whatever type of battery it is. And then you might have a model level table to provide a record for each battery type and its attributes, and then sort of do a table lookup depending on the battery the user selects. The behavior would be different. So yeah, 100%.
All right, perfect. All right, let me just grab sharing back at Adam here real quick to bring up PowerPoint. Maybe. Come on, share. Perfect. All right. As I mentioned, make sure I'm sharing it. Definitely. You can see that, right, Adam?
Yes, I can.
All right. All right. As I mentioned, here's both my email address and Adam's. So if you do want to reach out, if a question was asked and we did not get to it, or because of the kind of change in WebEx, if you wanted to ask a question and couldn't figure out how to do it, you can feel free to reach directly out to either of us or both of us, and we will get back to you. Otherwise, thanks everyone for attending. And real quick here, July the 16th, so just under a month from now, will be our next one, Work Harder, Not Smarter, a data-driven approach to modeling labor. And by the time we get to that July 16th, we will have our schedule in place for August/September/October. There are summers we usually take off August because of vacations, etc. So we will more than likely take off August and we'll be back in September, but we will have a schedule at our next webcast on what our plans are going into the fall. So thanks again for everyone attending. We appreciate your time today. If you're watching on recording, thanks for watching the recording, and we will see everyone soon. Goodbye.